Practice problem 16. A study was conducted to determine the relationship between the number of people in a family and the level of embarrassment from nudity. A scale from 1 to 10 was used to determine the level of embarrassment, with 10 being the most embarrassed. The study surveyed 100 people in 15 states across the United States. The state averages are presented in the table. And then we get a table that has some different family sizes and some different embarrassment ratings. And obviously, this is some states. There are 15 of them. I don't know how those states were chosen. We're not going to focus on whether this was a good study. We're going to focus on what data we can do, what analysis we can do given the data we have. Because part A is going to tell us to use a calculator to find the equation for the least squares regression line. Interpret the slope and y-intercept in the context of the scenario. And then part B is to use that least squares regression line to predict the embarrassment level for a family of 10 and show our work and explain the issue with our answer. So I'm not going to follow instructions. I don't feel like using a calculator because calculators that do this are, they cost money. They eat batteries. Maybe I don't have one handy. But what I can do is I can copy and paste this into a Google Sheet. And then I have all of my data in a Google Sheet. I already had this loaded up in another tab, just the empty Google Sheet. And then I can pick any cell that isn't in my data, which I didn't have to type in by hand because I just copied and pasted. Go up to the formula bar here, above the spreadsheet and below the menu, and type equals line ST, while actually with the cursor in that particular formula bar. And you'll see it pops up a little helper about what this function does. This function is a best fit linear trend via least squares. And when I start my parentheses, it starts giving me help about what's supposed to go in there. It says the first of the 4 arguments it takes is known data y. So where's the stuff that should be my y-axis, or my y data, my outputs? And then it's going to want, where's the stuff that's my x data, my inputs? You can also think about this in terms of independent and dependent variables. X would be the independent variable. Y would depend on X and be the dependent variable. For this class, we're going to want it to calculate B. We're always going to set that flag as true, because that's saying, you know what, mine might not go through 0, 0. It might have a y-intercept somewhere other than 0, 0. It's not guaranteed to be proportional. Just linear, not proportional. Verbose is if I need more information than just the equation for the line. For this problem, I don't. If I do, then I would set that flag true. So in this case, I know I want my output to be the embarrassment rating. That's my dependent variable. So I select those. I've selected the range B2 to B16. I could have typed in B2 colon B16 if I'd wanted to, or I could have clicked in B2, held down Shift, and then clicked in B16. I then use a comma to separate my arguments and put in my next argument, which is going to be my X data. That's going to be family size, because that is my independent variable. Once again, I select that range, and then I use a comma to say I'm done with that argument. These next two are true-false flags. So rather than giving it data, I'm just saying what I want it to do with that information. So yes, I would like to have you calculate a B to get it in the form y equals mx plus b rather than y equals mx. And I don't care about verbose for this, so I'm going to set the second flag as false. I'm going to linger on this for just a minute because this is pretty much what it's going to look like every time you use this function in this class. You're going to have the range that your output's in, and you'll see it's even helping me. It's kind of got an orange highlight around that. And then this is purple for my input, and it's got a purple little highlight around that. And then this is always going to be true, and this is probably always going to be false, depending on what kind of question you're being asked and if you want some of the rest of that data. And I'll put a help page in the comments, that in the video description and in the comment in the class review, for where you can go for more information about what you'll get if you put in verbose. So after I'm happy with how I have this set, I can hit enter. And then over here, it's going to spit out a slope and a Y-intercept. A Y-intercept, not an I-intercept. Oh, typos are fun. A Y-intercept. So that would mean my equation would actually be, and I will switch over to the document camera for this because I want to talk about it a little bit, but I will write it down as well. So we're going to switch to the document camera. As soon as I find my mouse, there it is. So the equation is going to be y hat. Our prediction is that we'll have a y-intercept at 3.40, I'm going to go with 2. There were more numbers. I don't feel like including them. How much precision to include here is kind of one of those things that you get to decide. If I'm going to keep it computer-based rather than calculate by hand, I'm going to keep a lot of stuff. If I'm going to do it by hand, feels like 3 digits after the decimal place are enough. And then my slope was 0.803x. So now I've got my equation. I want to go back to Google Sheets and show you something else real quick before we go on with interpreting this and talking about it. Because some of you may do better if things are more visual. So I want to show you how to get some visuals in Google Sheets. So here we are back in our spreadsheet. And this time I'm going to select my data. I clicked cell A1, I held down shift, and I clicked cell B16, and that highlighted my entire table. And then I go into the insert menu and choose chart. And then it thinks about it for a minute, and it just made a scatter plot for me. That's pretty much exactly what I wanted in terms of a scatter plot. It's got family size along the x's, it's got embarrassment rating along the y's. And so that's kind of cool because it lets me see the shape of my data and kind of go, I wonder if linear was a good choice for this. And I might have opinions. But what's really cool, and I can mess with some stuff over here if I need to, is I can go into customize over here, and there's a bunch of stuff I can customize. But if I go into series and scroll down, I can click trend line, and it puts in a nice little line for me that's exactly the same line we've been calculating. I can label it with the equation, and there's my least squares regression line. It has, it's in the other order. It put slope and then y-intercept, which is the opposite of what we've been doing, but it's the same line. And you'll notice it's a little less precise than we got with the numbers. This just says 3.4, and this one we got 3.4 and some stuff. So depending on how much precision I need, I might need to do this with the function rather than just with this. I could also play with the type. I could say, I don't think this is linear. I think maybe this is polynomial. How does that work? And so then it'll make its best guess at a polynomial and give me a different equation. So I could do a lot of different stuff here. This is beyond the scope of our class. We're worrying about linear, but there's a lot of neat stuff in here. And this is a pretty powerful tool. You should have a reason why you're using that model, and tie it back to why that makes sense. But this is a way to see visually what's going on. So now we're done with Google Sheets. We have 2 different ways to get that equation in Google Sheets. One of them using the chart editor, customize, series, trend line, label, use equation, and the other one with that line st function. And once we have that information, we can go back to our work. We've got the equation there. And we need to actually do some things with that because they asked us to find the equation, so we've done that. Interpret the slope and the y-intercept in the context of the scenario. So this is our slope, and this is our y-intercept. In the context of the scenario, the slope is saying this is how much more embarrassed we predict people will get as their family size increases. So if the family size go up by 1, they're going to rate themselves 0.8 more on our 1 to 10 scale on average as embarrassed. So that's saying that as the family size gets bigger, they tend to be more embarrassed. And looking at that growth, that it's going to be 0.8 as family size goes from 1 to 2, 0.16 as it goes up to, and so on, because I'm going to be plugging in values for x. And so I can use this to predict the embarrassment for various family sizes. For a family size of 0, we would predict 3.4. And obviously a family size of 0 is kind of nonsense. What would it be like to have no family whatsoever? And like that, like you always have you. You're a one-person family, even if you're living by yourself. So it doesn't make literal sense. And sometimes that's the case with these models. Like there are boundaries on what they make sense. And so that's kind of part A. Then the next thing we need to worry about is part B, which is to use this least slope regression line to predict the embarrassment level if there were 10 people in our family. And our data didn't include any families that big. The biggest, but we're looking at the averages for different states. So they probably had some families that big, maybe, in their data. I don't know. Let's see. Does this model work? Because we built it based on state averages, and the highest state average was 7. So does it work if we have a family size of 10? So to figure that out, I want to know what is our prediction. The y-intercept isn't going to change. The slope isn't going to change. But now I need to plug in 10 for my x. So my x became 10. So I need to multiply this by 10 and then add the result of that to this number. Because I'm multiplying by 10, I can use a little mental math trick and just move this decimal point over 1, because we use a base 10 system, and so place value says that I can just move the decimal point because I'm multiplying by 10. And this isn't going to work sense is already tingling, but I'm going to persist and I'm going to finish off the problem. But I'm kind of seeing, 3 plus 8 is more than 10, and this is supposed to be a 1 to 10 scale, but, what is it specifically? I want to see the specific nature of the problem. So our model predicts, when I add these together, that if I have 10 people in my family on a 1 to 10 scale, they're going to rank embarrassment at over 11. Their embarrassment goes up to 11. So the model didn't work. And sometimes that happens. If you're picking something that is outside of the numbers that were in your model, the model didn't take into account that you might have those kind of input values. We would also probably get some pretty strange answers for negative numbers. This model is going to do a good job of predicting for numbers that are very similar to the numbers that we gave it to build its predictions with. And the numbers those were, it had 1s, 2s, 3s, 4s, 5s, and a 7. So it didn't have a lot of information about things as big as 10 when it was deciding that this was the line. And so our model doesn't work for very large families. So, that is this problem, and I apologize for spending 15 minutes explaining it.